Imagine a hunter, sleek, hyper-efficient and engineered for pure speed. If you've spent any time exploring the rugged bush or the open woodlands across Australia, you've likely seen this archetype in action. It is an animal built for explosive momentum. It stalks, it coordinates, it strikes with devastating precision. This is how we typically understand mammalian survival on the Australian continent. Aggressive, highly energetic, and fiercely competitive. Take a standard, widespread native predator, say, a spotted-tailed quoll or a dingo. Their lives are a non-stop high-stakes race. They hunt live prey, defend vast territories, reproduce in intense seasonal windows, and burn through energy like a wildfire sweeping through the dry eucalyptus scrub. Their existence is fast, vibrant, and driven by relentless activity. Now, I want you to completely forget that entire blueprint of life, deep within the ancient, nutrient-poor forests of Tasmania and the damp, shadowed gullies of southeastern Australia. There is a landscape where the rules of high-speed survival simply do not apply. During the freezing depths of the southern winter, when alpine winds whip across the Great Dividing Range and temperatures plummet below freezing, standard predatory strategies become a recipe for starvation. In these harsh environments, energy is the rarest commodity on Earth, and it is hidden in the dense undergrowth that an absolutely baffling creature makes its home. It is a living contradiction. An animal that looks like a primitive relic from a bygone era, yet possesses a survival strategy so bizarrely efficient it blurs the line between a mammal and something altogether otherworldly. This creature existed in Australia long before the first marsupials arrived, quietly enduring while grander, faster species vanished from the fossil record entirely. Yet the strangest thing about it isn't its ancient lineage or its peculiar appearance. The strangest thing is how it manages its internal engine to survive where almost nothing else can. To truly understand how profoundly weird this creature is, we have to look back at the conventional success stories of Australian wildlife. The typical mammalian insectivore or small carnivore in Australia is an absolute powerhouse of metabolic activity. Consider the agile antechinus or any number of small marsupials tearing through the leaf litter of the Northern Territory savanna or the coastal forests of Queensland. They are hunting machines. They possess sharp eyesight, lightning-fast reflexes, and a body temperature that remains constantly high and tightly regulated. They consume massive amounts of high-calorie insects and small vertebrates daily just to keep their internal furnaces burning. If they stop moving, if they fail to find a meal for even a single day, their system collapses. It is a high-risk, high-reward lifestyle that has worked beautifully for thousands of generations across the diverse biomes of the Australian continent. But our mystery creature rejects every single tenet of this fast-paced Australian survival guide. Its name is the short-beaked echidna, known scientifically as Tachyglossus aculeatus. When European naturalists first encountered this animal on the shores of Australia in the late 18th century, they were utterly paralysed by confusion. It didn't fit into any known taxonomic box. It had hair like a mammal, but it was modified into sharp, formidable spines. It had a long, bird-like snout, no teeth, and a sticky tongue designed to vacuum up ants and termites. Most shocking of all, early observers eventually discovered that this creature laid soft-shelled eggs like a reptile or a bird. Yet nourished its hatched young with milk, secreted directly from skin glands within a primitive pouch. When scientists in Europe tried to classify this strange Australian specimen, they hit an absolute brick wall. Structurally, its skeleton resembled an ancient reptile. Anatomically, its reproductive system was a complete anomaly, and behaviourally, it seemed to operate on a completely different timeline than any placental mammal or marsupial. In response to this evolutionary puzzle, taxonomists had no choice but to isolate it entirely. Along with the platypus, it was placed into its own distinct mammalian order, the Monotremata. The echidna represents an evolutionary branch that grew independently on the isolated landmass of Australia. A line that chose a radically different path millions of years ago and never wavered. Where a standard Australian marsupial relies on a highly active social structure or territorial aggression to secure its place in the ecosystem, the echidna chooses absolute solitude and a near-total lack of aggression. Go to the arid red centre of Australia or the dense coastal heathlands, and you will never find a pack or a cooperative colony of echidnas. They do not communicate with flashes of color or vocalizations. They do not patrol territories with aggressive displays. Instead, the echidna moves through the Australian landscape like a slow, deliberate shadow, completely detached from the frantic competition around it. Consider its physical build, which is the very first thing that leaves modern biologists in awe. An adult short-beaked echidna in the southern regions of Australia weighs between 2 and 6 kilograms, about the weight of a domestic cat. Its body is a compact, low-slung dome of solid muscle and dense spines, perfectly optimized for digging into the hard-baked earth of the outback. A sleek, high-speed predator requires long limbs and flexible joints, which demand immense amounts of daily caloric energy just to maintain. The echidna's low-slung, heavy-set anatomy is a masterclass in energy conservation. It is a body designed to move slowly, using minimal muscular effort to achieve maximum physical leverage when tearing open rotting logs or burrowing vertically into the soil. Even its coloration tells a story of survival based on concealment rather than display. While many birds and reptiles across Australia use vibrant, shifting colours to signal dominance or attract mates, the echidna is wrapped in a drab palette of earthy browns, blacks and straw-coloured spines. In the dappled light of the eucalyptus bush, this camouflage allows it to virtually vanish into the background notice. It does not need to run. It does not need to fight. It simply blends into the ancient terrain of the Australian continent, relying on an impenetrable armour of keratin and a metabolic rate so low it defies everything we think we know about warm-blooded animals. To appreciate the sheer genius of this creature's design, you have to look at how it interacts with the physical world, because the contrast between a short-beaked echidna and any other Australian mammal is nothing short of astonishing. Think about a standard native hunter on the Australian continent, like the agile antechinus or a spotted-tailed quoll. Their paws are equipped with highly flexible digits, sharp claws for climbing, and sensitive pads designed to grasp struggling prey. Their limbs are long, built for rapid acceleration and sudden directional shifts. This anatomy is a magnificent tool for active hunting, honed over millions of years of intense competition in the leaf litter of coastal forests. The echidna, however, possesses limbs that look like they were stolen from a completely different blueprint altogether. It has 5 powerful claws on each foot, but on the hind limbs, the second claw is elongated into a specialized grooming tool, used to scrape between its sharp spines. More importantly, its feet are turned backward. This unique orientation allows the echidna to dig with a rotating, shovel-like motion. When an echidna encounters a threat in the open Australian bush, it doesn't flee. It doesn't use a burst of speed to reach a hollow log. Instead, it begins to dig straight down into the dirt, using its backward-facing feet to displace earth horizontally. Within a matter of minutes, the animal sinks vertically into the ground, leaving only an impenetrable dome of sharp, outward-pointing spines exposed to the world. It is a defensive maneuver that requires almost no metabolic energy. Yet it renders the echidna entirely safe from virtually every land predator in Australia. But it is the echidna's snout and tongue that represent the true peak of evolutionary specialization. Where a dingo or a quoll relies on an array of sharp incisors and slicing carnassial teeth to tear meat, the echidna has abandoned teeth entirely. Its long, slender snout is a solid bone structure covered in highly sensitive skin. At the very tip of this beak sits a tiny mouth, barely wide enough to let a standard pencil slide through. Inside this snout sits a tongue that can extend an incredible 18 centimeters outside the beak, nearly half the length of the animal's entire body. This tongue is not just long, it is a masterpiece of biochemistry and biomechanics. It is coated in an incredibly sticky, mucus-like saliva produced by massive submaxillary glands that occupy a huge portion of the animal's chest cavity. When the echidna penetrates a subterranean termite mound in the dry outback, it fires this tongue in and out of its mouth at a blinding speed of up to 100 times per minute. The termites and ants adhere to the sticky surface instantly, and as the tongue retracts, the insects are pulled into the mouth and crushed against hard keratinous pads located at the back of the tongue and the roof of the mouth. This is a method of feeding that completely bypasses the need for heavy jaws or energy-expensive teeth. It is smooth, continuous, and exceptionally low in energy cost. And then we come to the brain and senses, where the divide between the echidna and the rest of the mammalian world becomes genuinely mind-boggling. If you examine the brain of a typical placental mammal or marsupial in Australia, the neocortex, the area responsible for complex processing and learning, is folded to increase surface area. But it is proportional to the animal's size and predatory needs. A dingo needs a highly developed visual and olfactory cortex to track prey across kilometres of open savanna. The echidna's brain, however, possesses a massive, highly convoluted frontal cortex that rivals the complexity of many primates. For a creature that spends its life vacuuming up ants in the dark undergrowth of Australia, this massive brain seems like an absurd evolutionary overexpenditure. The secret lies in what that snout can actually do. The tip of the echidna's beak is packed with a dense network of mechanoreceptors that detect tiny vibrations in the soil, but it also contains something far rarer: electroreceptors. There are roughly 400 of these specialized mucus-filled pores concentrated at the very tip of the snout. Aside from the platypus and a few select species of fish, the echidna is one of the only creatures on Earth capable of detecting the faint electrical fields generated by the muscle movements of living insects. When you see an echidna plodding slowly through a damp gully in Queensland or a forest in Victoria, swaying its head gently from side to side, it isn't just looking or sniffing. It is actively reading the electrical grid of the soil beneath its feet. It can pinpoint a buried colony of termites or a beetle larva hidden deep inside a rotting log without ever needing to see or hear it. This precise sensory guidance means the echidna never wastes valuable energy digging in the wrong spot. This absolute refusal to waste energy is mirrored perfectly in the echidna's internal physiology. Standard mammals maintain a remarkably stable, high body temperature, usually hovering around 37 degrees Celsius. This requires a relentless metabolic engine that consumes calories constantly just to maintain a baseline internal heat, even when the animal is completely at rest. The short-beaked echidna completely rejects this expensive thermal model. It maintains the lowest baseline body temperature of any active mammal on Earth, averaging just 32 degrees Celsius. Furthermore, its metabolism is a mere 1/3 of what you would expect for a mammal of its body mass. But it goes even further than that. The echidna is heterothermic, meaning it allows its internal temperature to fluctuate wildly depending on the environment and its activity levels. If the morning is cold in the alpine regions of New South Wales, the echidna's body temperature might drop to 25 degrees without causing the animal any distress whatsoever. It simply moves a bit slower, waiting for the ambient air to warm up. By refusing to fight the environment to maintain a rigid internal thermostat, the echidna saves an immense amount of daily energy. It is an internal engine optimized for an island continent characterized by unpredictable climates and poor soils, where a high-energy lifestyle is a dangerous gamble that many species eventually lose. This physiological flexibility reaches its absolute peak during the biting cold of the southern winter, and it is here that the echidna's strategy for enduring the harsh Australian climate turns into an act of complete survival wizardry. To survive winter, most highly active Australian mammals have to work twice as hard. A spotted-tailed quoll or a brush-tailed phascogale must hunt relentlessly through the freezing rain, burning massive amounts of fat reserves just to keep their internal core temperature from dropping to a lethal level. If the prey vanishes, they face a rapid cold death. The short-beaked echidna handles the winter crisis by simply opting out of the season altogether. In the elevated, snow-dusted forests of Tasmania and the subalpine regions of New South Wales, echidnas enter a state of true deep torpor, a prolonged hibernation that few other native mammals across Australia are capable of achieving. As the temperature plunges, the echidna retreats into a sheltered burrow beneath a rotting log or under a thick blanket of eucalyptus leaf litter. Its internal thermostat resets. Its metabolic rate collapses to a mere fraction of its already low baseline, and its body temperature plummets, sometimes dropping all the way down to a staggering 5 degrees Celsius during these deep bouts of torpor, which can last for weeks at a time. The echidna's heart rate slows to just a few beats per minute, and it may breathe only once every few minutes. By reducing its biological functions to the absolute bare minimum, it stretches its limited fat reserves over months rather than days. It doesn't need to hunt, It doesn't need to compete. It simply waits out the frozen months in perfect, icy stillness, insulated by the ancient soil of the Australian continent, when spring finally breaks across the Australian bushland. The echidna wakes from this deep slumber to face the most energy-demanding phase of its life, the breeding season. Yet even here, the reproductive cycle of Tachyglossus aculeatus is a stark rejection of standard mammalian behaviour, operating on a timeline that seems completely alien. Think of a typical Australian marsupial like a kangaroo or a wallaby. They invest heavily in a continuous reproductive cycle, utilising embryonic diapause to constantly have a joey in the pouch and another waiting in development. It is an efficient production line, but it demands a steady, reliable influx of resources. The echidna's reproductive strategy is built entirely on patience, safety, and a bizarre phenomenon known as the echidna train. During the late winter and early spring, an eligible female echidna moving through the woodlands of Queensland or Victoria will begin to emit subtle chemical signals. Soon, a single male will detect her scent and begin to follow her. Then another male joins, and another, until a line of up to a dozen male echidnas is trundling slowly through the undergrowth, nose to tail, behind a single female. This slow-motion parade can last for up to 6 weeks. The males show no overt territorial aggression. They do not engage in violent, energy-wasting combat like dingoes or kangaroos. They simply walk, wait, and endure. When the female is finally ready to mate, the males dig a circular trench into the dirt around her, pushing and jostling one another in a quiet test of physical leverage until a single dominant male secures his place. This elaborate ritual consumes plenty of time, but almost no blood or broken bones, a masterpiece of non-violent, low-risk competition perfectly suited to the energy-scarce Australian environment. What happens after mating is perhaps the most famous anomaly in all of Australian zoology. Roughly 3 weeks later, the female echidna develops a temporary, muscular fold of skin on her abdomen, a primitive pouch. Instead of giving birth to a highly developed placental infant or a tiny crawling marsupial joey, she lays a single, leathery, soft-shelled egg directly into this pouch. The egg is tiny, measuring barely over a centimetre in diameter, and is protected by a sticky coating that keeps it secure against her skin. For 10 days, the mother carries this egg, keeping it perfectly warm against her skin while she moves slowly through the bush. When the tiny hatchling, known affectionately in Australia as a puggle, breaks through the leathery shell using a temporary egg tooth, it enters a world entirely unlike that of any other mammal. The mother echidna has no teats or nipples. Instead, the puggle relies on 2 specialised milk patches inside the pouch. These are networks of modified sweat glands that secrete nutrient-rich milk directly onto the mother's hairs, which the puggle laps up continuously. The puggle remains hidden in the safety of the pouch for about 2 months, growing rapidly on a diet of exceptionally fatty milk. But eventually, a major physical problem arises. The young echidna begins to develop its first sharp spines. For the mother, carrying a pouch full of needles through the rough Australian terrain quickly becomes an impossible task. Rather than abandoning the young or risking its safety in the open forest, she digs a specialised, secure nursery burrow deep underground. She places the puggle inside, seals the entrance with loose dirt to camouflage it from predators like goannas and feral cats, and walks away. For the next several months, the mother returns to this nursery burrow only once every 5 to 7 days. She digs her way inside, allows the puggle to gorge itself on milk for a few hours, and then seals the burrow once more before returning to her solitary foraging. This incredibly sparse visitation schedule is a massive departure from the intensive parental care seen in most mammals. It allows the mother to spend almost all her time rebuilding her own energy reserves across the changing Australian seasons, while the young puggle remains perfectly safe, hidden away in a climate-controlled subterranean bunker where no surface predator can find it. This remarkable subterranean childhood marks the beginning of an incredibly long, slow-burning life, where a standard small mammal across Australia might burn brightly and perish within a couple of seasons. A short-beaked echidna playing the long game can live for up to 50 years in captivity, and well over 30 years in the unpredictable wild of the Australian bush. By choosing absolute solitude, ignoring the frantic race for high-calorie rewards, and engineering a body that treats every single joule of energy as a sacred resource. This ancient creature hasn't just survived on the Australian continent. It has outlasted nearly every competitor that ever tried to outrun it, today, as the modern world reshapes the diverse ecosystems of Australia. The echidna's unique survival blueprint faces its modern test. Urban sprawl, land clearing, and the devastating impact of introduced predators like feral cats and foxes have placed immense pressure on native Australian wildlife. Yet, while many highly specialised marsupials are struggling to hold on in fragmented habitats, the short-beaked echidna continues to show up in the most unexpected places. Because they can feed on a wide variety of ant and termite species and can tolerate wild shifts in temperature, they are found in almost every single habitat type on the Australian continent. From the snow-covered peaks of Mount Kosciuszko to the arid heart of the Simpson Desert, and even tucked away in the leafy suburban gardens of Brisbane and Melbourne. This brings us to a crucial realisation about how we interact with this unique piece of Australia's living heritage. Because echidnas are relatively slow-moving and appear approachable, they are frequently encountered by bushwalkers and wildlife enthusiasts. However, observing these ancient creatures requires a deep commitment to non-intrusive wildlife ethics. When an echidna senses a human approaching too closely, its immediate instinct is to freeze, drop its head, and begin wedging itself into the soil or undergrowth. To an untrained eye, a stationary echidna might look calm, but internally, its heart rate spikes and it experiences significant stress. Ethical wildlife viewing in Australia means giving these solitary survivors a wide berth. Approaching an echidna to force a reaction, trying to handle them, or crowding them for a photograph disrupts their delicate energy-saving routines. If they are forced to abandon a half-excavated termite mound or spend precious energy digging a defensive trench on a hot afternoon, it directly impacts their tightly budgeted metabolic reserves. The best way to appreciate an echidna is to sit completely still a few meters away and simply watch. If you remain quiet, the animal will eventually regain its confidence, extend its sensitive snout, and continue reading the invisible electrical currents of the Australian soil, completely undisturbed, for over 120 years. Science has attempted to map every corner of the natural world, yet this spine-covered anomaly remains beautifully enigmatic. We still don't fully understand the complex neural processing occurring inside that massive frontal cortex, nor do we know the exact genetic triggers that allowed it to bridge the gap between reptile and mammal so seamlessly. The short-beaked echidna is a living